Dear students, I am Ramesh, Chemistry faculty from Vidya Mandir Metric Higher Secondary School, Uttangarai. Let us discuss about theories of catalysis. And when the reaction occurs, so when the chemical reaction occurs, what will happen? When the chemical reaction occurs, we may take that the reactants are taken. So here it is the energy and here the energies of the reactant. So each reactant have some energy. Now the reactant not directly converted into product. What will happen? Here the reactant molecule get converted into product. Before converting into product, it crosses some energy barrier. And in this energy barrier is nothing but activated complex. So activated complex, so every reactant molecule is cross the activated complex. So the amount of energy required to reach the activated complex is nothing but energy of activation. So what is energy of activation? The amount of energy required for the reactant molecule to get activated, and after the reactant molecule get activated, then it is converted into product. Now it is a normal stage. If you are using a catalyst, what will happen? And you know that. What do you mean by catalyst? Catalysts are the chemical substances which alter the rate of the reaction, and after the completion of the reaction, and it remain unchanged in mass and chemical composition. So if you are using a catalyst, what will happen? The activation energy. If you are using a catalyst, then the reactant molecule has a new path which is converted into product. That is, the energy of activation decreases. Now, absence of catalyst, the energy of activation here and here, it is high. In presence of catalyst, we are taken here, it is a catalyst effect. So the activation energy, it is A1 and that A2. So the activation energy decreases in presence of catalyst. So the reactant molecule is converted into product in a new path, that is a lower activation energy. So what will happen by presence of catalyst? So the activation energy is lowered. Then what will happen? More reactant molecule is cross the energy barrier, then it is converted into product. So we are using a catalyst. So using a catalyst, what will happen? Activation energy decreases. So what will happen? More reactant molecule cross the energy barrier, which is converted into product, So what about the rate? Here the rate of the reaction increases while using a catalyst by decreasing the activation energy. So rate of the reaction increases by decreasing activation energy. Then it is theories of catalysis. Now there are two theories which explains the catalyst. The first theory is intermediate compound formation theory and adsorption theory. So we are taking that the first theory, it is intermediate compound formation theory. intermediate compound formation theory. Okay. And this theory is applicable only for homogeneous catalysis. So here it is applicable only for homogeneous catalysis. Homogeneous catalysis. So what do you mean by homogeneous catalysis? What do you mean by homogeneous catalysis? The reactant and the catalyst are in same phase. Then it is homogeneous. Now, according to this theory, the reactant molecule, we are taking the reactant molecule, is reacted with the catalyst and form an intermediate. And form an intermediate. And the intermediate, it will use the product. The intermediate gives the product. So, the products are not formed directly from the reactant. The products are formed from the intermediate, which is less stable compound. Now, if you have taken the examples, that is A is the reactant and B is also the reactant, and the reaction takes place in absence of catalyst and form that AB, the addition compound. And A is reacted with B in presence of catalyst and form that AB. Now, what is the difference between these two? The first one in presence of absence of catalyst. The second one in presence of catalyst. Then, what about the activation energy? The activation energy decreases in presence of catalyst. So, here it has low EA value and it has high EA value. Now, according to intermediate compound formation theory, what happened here? One of the reactant is reacted with the catalyst and form an intermediate. So, what about here? We are taking the step 1. Here, A is reacted with the catalyst C and form the AC. And it is a intermediate compound, which is less stable. Then, after the intermediate formation, the intermediate is reacted with another one reactant and form the desired product under that catalyst. So, we are taking, that is step 2, and here what will happen? Here AC is a intermediate. AC is a intermediate. The intermediate is reacted with another one reactant and form the desired product AB and the catalyst C. So, it is intermediate compound formation theory. So, the same reaction which is occurs in 2 steps. By comparing the EAs of 2 reactions, both are it has a lower EA value. So, in presence of catalyst, the activation energy decreases so that the reactant molecule form an intermediate and the intermediate reacted with another one reactant and formed the desired product and the catalyst. Now, we may take the examples of intermediate compound formation theory, the first example. And we are taking that Friedel-Crafts reaction. So, Friedel-Crafts reaction we have taken. What is that Friedel-Crafts reaction? There are 3 types of Friedel-Crafts. Friedel-Crafts methylation, Friedel-Crafts acetylation and Friedel-Crafts benzoylation. And here we are using that is benzene. When benzene is treated with methyl chloride. In presence of anhydrous AlCl3. So, Friedel-Crafts reaction, we are using that anhydrous AlCl3. Then, it will be formed that that is C6H5CH3 and that is HCl. One of the hydrogen is reacted with the Cl and formed that HCl. So toluene is the product. Now, according to intermediate compound formation theory, what will happen? Then the catalyst is reacted with one of the reactant and form an intermediate. The intermediate is reacted with the other reactant and form the desired product. So what is the catalyst here? AlCl3. So here this AlCl3 is reacted with one of the reactant CH3Cl, methyl chloride, and form an intermediate. Then here it is AlCl4 minus and that CH3 plus. Then these are intermediate. So it is a intermediate. So intermediate is reacted with another one reactant. What is the another one reactant? Benzene is another one reactant. So here when benzene is reacted with the intermediate, that is CH3 plus and AlCl4 minus, then form the desired product. What is that? C6H5CH3 toluene and that here that is AlCl3 and that HCl. So at the end of the reaction, the catalyst remains unchanged. Then we are taking the second example. Oxidation of potassium chlorate in presence of MnO2. We are taking potassium chlorate. Here the overall reaction KClO3 in presence of MnO2. Then it formed that is KCl, that is 2KCl and that O2. So 2O2 and 3O3. So here 2 and that 3. Now what according to intermediate compound formation theory? The catalyst is reacted with reactant and form an intermediate. Now we are taking the catalyst MnO2 is reacted with KClO3. Then MnO2 is converted into MnO3 and that here KCl is formed. So we are taking 6 MnO2 and 6 MnO3 and here 2 KCl and here that is 2 KCl. So here 12 and that 6, 18. So oxygen 18, it is balanced. Now what will happen here? That is potassium chloride is formed, one of the product is formed. Then another one product we want to form. So here there is 6 MnO3 is decomposed and formed a 6 MnO2 and that oxygen. So that here 18 and 12, so that it is a 6. So oxygen is also formed. So the catalyst is reacted with the reactant and form the intermediate. And what is the intermediate? MnO3 may act as an intermediate. Then intermediate gives the desired product. And the next example, we are taking oxidation of hydrogen. So we are take hydrogen and it is reacted with the oxygen in presence of copper and form that H2O. So we are take of H2O of O2. Now here these are the reactant and the copper is a catalyst. So what will happen here? When copper is reacted with oxygen and found that is Cu2O. So that here 2Cu and of O2. Now it is the intermediate. So Cu2O may act as the intermediate. And the intermediate is reacted with the other reactant. So it is an intermediate. So here there is Cu2O is reacted with the hydrogen and form the desired product H2O and the 2Cu. So we are getting the product and the catalyst remains unchanged. Then the fourth reaction, we are take oxidation of HCl. Oxidation of HCl by air. So we are take HCl is reacted with oxygen in presence of CuCl2, cupric chloride. Then what will happen? It is converted into H2O and that Cl2. And 2 chlorine is there, so that 2 hydrogen, so that it is 2 hydrogen. Oxygen, it is of oxygen. Now, according to intermediate compound formation theory, what will happen? Here, this CuCl2 is reacted with that oxygen and formed the intermediate. But here what will happen? CuCl2, it is converted into Cu2Cl2 and the chlorine. One of the product is formed. So 2CuCl2. Now this Cu2Cl2, we are take here Cu2Cl2 is reacted with the oxygen and formed the Cu2OCl2. Cu2OCl2 is Cu2OCl2 is reacted with HCl. It is reacted with HCl and form the desired product, that is H2O and CuCl2. So here we are taking, that is 2 and here 4Cu, so 4CuCl2 and 4HCl and that 2H2O. So here CuCl2 is the catalyst. CuCl2 get altered, become Cu2Cl2 and the intermediate is Cu2OCl2. So here the intermediate compound formation theory, the reactant gives an intermediate and the intermediate gives the desired product. So the intermediate compound formation theory explains the homogeneous catalysis and also explains the concentration of the reactant and the catalyst increases, the rate of the reaction increases. Now, what are the limitations of intermediate compound formation theory? And it fails to explain heterogeneous catalysis. Heterogeneous catalysis. So it does not explain the catalytic poison action and also that promoter's action. And to explain this, we are taking that adsorption theory. So we are taking the next theory, it is adsorption theory. And adsorption theory is explained by long mu. It is explained by long mu. And this adsorption theory is applicable for heterogeneous catalysis. So it is applicable for heterogeneous catalysis. What do you mean by heterogeneous? The reactant and the catalyst are in different phases are known as heterogeneous catalysis. And here, according to adsorption theory, the reactant molecule get adsorbed on the surface of a catalyst. So we are taking the reactant molecule. So reactant get adsorbed on the surface of a catalyst. Then what will happen? The adsorbed reactant molecule get activated and form a desired product. So here the adsorbed reactant molecule, adsorbed reactant molecule get activated, form activated complex, and give the desired product. So this is the adsorption theory. So according to adsorption theory, reactant molecule is get adsorbed on that surface of a catalyst and form that activated complexes and converted into product. Now we are taking some steps involved in adsorption theory. What are the steps? So the first step we are taking, that is step 1, that is the reactant molecule diffuses from the bulk to surface. So we are taking that here a nickel catalyst. And in this nickel catalyst we are taking that hydrogen, and here there is a hydrogen that will be present on that voids. So here there is a hydrogen and hydrogen. So nickel contains a hydrogen. The reactant molecule we have taken, that is ethylene molecule. Here it is CH2 double bond CH2. The reactant molecule diffuses from the bulk and it is nearer or closer to the catalyst surfaces. Okay, so it is the step 1. So reactant molecule diffuses from bulk. Reactant molecule diffuses from that bulk and it is nearer to that surface of a catalyst. Now we are taking that here it is step 2. And in a step 2, the reactant molecule get adsorbed on the surface of a catalyst. So the reactant get adsorbed, on the surface of the catalyst. Okay, listen, we are taking that here there is a nickel, here it is a nickel, and here there will be a hydrogen. So hydrogen that will be present in that voids. Hydrogen is present in that voids. Now what will happen? The ethylene molecule get adsorbed. So here it is ethylene, CH2, double bond CH2, and it is a sigma bond and the pi bond. To compare the sigma bond and the pi bond is weakest. So it is get adsorbed by a partial bond or weak van der Waals forces. If it is a chemical adsorption, then bond formation is occurred. If it is a physical adsorption, and van der Waals forces of attraction is occurred. So it is a second step. Then it will be get activated. So we are taking, that is step 3. So we are taking, that is the nickel, and here there is a hydrogen. So here there is a hydrogen. So here that is a CH2 bond CH2 is giving that hydrogen and that hydrogen. So it is get adsorbed and that activated. So adsorbed reactant get activated and form a desired product. Now we are taking, that is a step 4. What is the step 4? We are taking, that is a step 4. So here the nickel catalyst we are taking here the nickel, and here the hydrogen is present on the voids of a nickel. Then it is converted into product CH3 bond CH3. Now it is get dissolved. There is no forces of attraction between the product, because it is the product and the catalyst. Now the step 5 we are taking, that is step 5. Here product molecule is diffuses from the surface of a catalyst. So we are taking the product diffuses from surface of a catalyst. From the surface of a catalyst. So these are the steps involved in that adsorption theory. Now we are taking a catalyst and it is active centers. Active centers. What are active centers? A catalyst does not have the smooth surface. If you are taking the nickel catalyst, here it is the nickel catalyst, and it does not have the even surfaces, and it has some steps like this, and also cracks. So it is the steps, and that here there is a cracks, and also that there is a corners. So here it is a cracks and corners and edges, and this part has greater residual forces, where it is the steps and cracks and the corners, and it has highest residual forces of attraction. Force of attraction. So these spots have highest forces of attraction towards the reactant. So the reactant molecule get adsorbed on this part and get activated, and it is converted into product. Now these parts are considered as the active centers. Active centers. Now, if it has a more active center, what will happen? It has more active centers. More active center. More active center, the reactant molecule is easily get adsorbed and activated. So, the rate of the reaction increases. So, here the rate increases. The rate of the reaction increases. Okay. Now, we are taking that here the adsorption theory, which explains the catalytic poison. And according to adsorption theory, if the catalytic poison is present, then it will block the active centers. It will block the active center. So what will happen? Adsorption get decreased. When adsorption get decreases, then the rate of the reaction is also decreases. So catalytic poison blocks active center. Active center. So that the rate decreases. So rate decreases. Rate decreases. Then, if it is a promoters, what will happen? The number of active center increases. Number of active center increases. So, what will happen? More number of active center, then it will be produces more adsorption, then the rate of the reaction increases. So, here more active center in presence of promoters. So, promoters increases the active center, so that the rate of the reaction increases. So it explains heterogeneous catalysis, and also it explains the action of promoters and catalytic poison. So it is adsorption theory. Thank you.